Welcome, everybody. This episode will be a real treat. You'll hear how multiverse scientists support the varied multiverse premise, the claim that the constants of nature vary from universe to universe, using the very same evidence that we use for the existence of God.
It might sound strange that we could come to the opposite conclusion as multiverse scientists when we're all basing it on the same evidence of fine-tuning, but we'll explain exactly how that's possible.
You'll hear how multiverse scientists harbor an unjustified hidden premise that incorrectly allows their entire line of reasoning to make sense.
And we'll show that when this premise is dropped, fine-tuning points directly to the existence of an intelligent cause. I'm Rabbi Aaron Zimmer.
And I'm Rabbi Dr. Eli Fader, and this is Physics to God. In the previous episode, we explained the theory of eternal inflation, and for the sake of argument, granted that multiverse scientists have established the existence of an infinite number of parallel universes.
But to explain the fine-tuning of the constants of nature without an intelligent cause, multiverse scientists don't only need evidence for an infinite number of universes. They also need evidence for the varied multiverse premise, that the constants vary from universe to universe.
In this and the next episode, we'll explain the two ways multiverse scientists attempt to support the varied multiverse premise. In this episode, we'll explain how they infer it from the astonishing fact that the constants are fine-tuned to produce a universe with intelligent life.
As counterintuitive as it may seem to use fine-tuning to support infinite randomness, this method gained much prominence after the 1998 discovery of the fine-tuning of the cosmological constant.
Okay, Aaron, I think we're getting ahead of ourselves. Let's start with the scientists presenting their argument.
It's a good idea, Ellie.
Because different people use the term multiverse to mean very different things, physicist Max Tegmark, one of the leading proponents of multiverse theory, proposed a categorization system for the different types of multiverses.
Tegmark's level 2 multiverse is an infinite number of universes that each have different constants, what we've been calling a varied multiverse. Besides using a varied multiverse to explain fine-tuning by chance alone, Tegmark and others go so far as to use fine-tuning in our one universe as evidence for the existence of a varied multiverse.
We'll read two quotes from Tegmark in a minute. But before that, I just want to preface it by saying that it's going to sound a lot like Tegmark is making the fine-tuning argument that we use to point to God. But he's not. Instead, he's using the discovery of fine-tuning to justify the varied multiverse premise. Go ahead, Aaron.
In his 2003 Scientific American article, Parallel Universes, Tegmark discusses fine-tuning as evidence that supports his level 2 multiverse. In the subsection called Evidence, he writes the following. Cosmologists infer the presence of level 2 parallel universes by scrutinizing the properties of our universe. These properties, including the strength of the forces of nature and the number of observable space and time dimensions, were established by random processes during the birth of our universe. Yet they have exactly the values that sustain life. That suggests the existence of other universes with other values.
Before we explain why Tegmark thinks that fine-tuning supports the varied multiverse premise, let's take another quote where Tegmark gives a few examples of fine-tuning. He says as follows, changing their values by modest amounts would have resulted in a qualitatively different universe, one in which we probably would not exist. If protons were 0.2% heavier, they could decay into neutrons, destabilizing atoms. If the electromagnetic force were 4% weaker, there would be no hydrogen and no normal stars. If the weak interaction were much weaker, hydrogen would not exist. If it were much stronger, supernovae would fail to seed interstellar space with heavy elements. If the cosmological constant were much larger, the universe would have blown itself apart before galaxies could form. Although the degree of fine-tuning is still debated, these examples suggest the existence of parallel universes with other values of the physical constants.
Given that Tegmark and other multiverse scientists use the multiverse to explain away fine-tuning, it might seem a bit circular for them to use fine-tuning as evidence to support the varied multiverse premise.
But here's how they do it. Their argument begins almost exactly like the fine-tuning argument we presented in episode 2 of our first series, with the problem that Richard Feynman called one of the greatest damn mysteries of physics.
By the second half of the 20th century, modern physics had been somewhat successful in moving towards realizing physicists' dream of discovering a theory of everything. But the specific values of the constants presented a unique challenge. Physicists didn't want to posit that the constants, which appear to be an ugly list of data, are themselves uncaused ad hoc additions to an otherwise beautiful theory of everything. Rather, they wanted to show the values of these constants emerge from a master law of nature.
But the mystery was, how can a theory of everything determine precise numbers like 137.035999139? This mystery emerged from the fact that the numbers seemed completely arbitrary, with no apparent rhyme or reason for their values. Since theoretical physics allowed the constants to have almost any value whatsoever, the mystery was, what caused them to take these particular values and not any others?
The discovery of fine-tuning provided the all-important clue, which illustrated that the values of the constants were not as arbitrary as they had at first seemed. Beginning in the 1970s, scientists had started to slowly realize that if these numbers were slightly different, intelligent life could not exist.
Over the decades, it became evident that the precision of the fine-tuning was too great to be chalked up to a lucky coincidence, as the odds of getting all the values within the correct ranges are staggeringly low. The 1998 discovery of the extreme fine-tuning of the cosmological constant put the nail in the coffin. It became clear that lucky chance can't reasonably explain the fortunate values of the constants.
While it couldn't be denied that fine-tuning is a vital clue for explaining the constants, its discovery presented a new problem. This is because modern science generally proceeds by explaining how the laws of nature cause complex phenomena in the universe. For example, the laws of physics cause atoms to interact in a way that brings about molecules. But fine-tuning seems to indicate the exact opposite, that somehow the end result of intelligent life is causally related to the specific quantities for each constant. From the ordinary scientific perspective, this seemed backwards.
The problem raised by fine-tuning forced a shift in the way many physicists understand the universe. Assuming there's only one universe, and that an intelligent cause for this universe is an impossibility, there is no way to explain the fine-tuned constants within the classic paradigm of science.
The only way to explain fine-tuning without an intelligent cause is to posit two premises. One, that there exists infinitely many universes, and two, that each of these universes has different values for the constants.
Based upon these two premises, the fine-tuned values of our constants only give the appearance and illusion of order, when in fact their values are truly random. The fact that we happen to observe these special values is only because our very existence is only possible in a universe with the perfect values that allow for intelligent observers. This is called the anthropic principle.
A clear example of this approach of explaining fine-tuning through a multiverse can be found in the book Just Six Numbers, written in 1999, in which cosmologist Martin Rees shows how our universe depends upon the fine-tuning of 6 specific numbers. After scientists discovered the incredible fine-tuning of the cosmological constant a year earlier, Rees was one of the first to argue that the best explanation for fine-tuning was that the constants varied through an infinite multiverse.
Even though the following quote is a bit lengthy, we think it's worthwhile because you get to see Rees spell out his thinking step by step. Here's Rees. In our universe, intricate complexity has unfolded from simple laws. But it's not guaranteed that simple laws permit complex consequences. Indeed, we've seen that different choices of our 6 numbers would yield a boring or sterile universe. Similarly, mathematical formulae can have very rich implications, but generally they don't. There are various ways of reacting to the apparent fine-tuning of our 6 numbers. One hard-headed response is that we couldn't exist if these numbers weren't adjusted in the appropriate special way. We manifestly are here, so there's nothing to be surprised about. Many scientists take this line, but it certainly leaves me unsatisfied. Others adduce the tuning of the numbers as evidence for a benevolent creator who formed the universe with the specific intention of producing us, or less anthropocentrically, of permitting intricate complexities to unfold. If one doesn't accept the providence argument, there is another perspective, which, though still conjectural, I find compellingly attractive. It is that our Big Bang may not have been the only one. Separate universes may have cooled down differently, ending up governed by different laws and defined by different numbers. This may not seem an economical hypothesis. Indeed, nothing might seem more extravagant than invoking multiple universes. But it is a natural deduction from some, albeit speculative, theories, and opens up a new vision of our universe as just one atom selected from an infinite multiverse.
The speculative theories that Rees mentions primarily refers to the theory of eternal inflation, which he uses to support the infinite multiverse premise. Rees then proceeds to raise the key issue of the variability of the constants, arguing that the only possibility that doesn't leave us with a perplexing mystery is that the numbers change from universe to universe.
Rees continues as follows. If there are indeed many universes, the next question that arises is, how much variety do they display? The answer again depends on the character of the physical laws at a deeper and more unified level than we yet understand. Perhaps some final theory will give unique formulae for all of our 6 numbers. If it were to, then the other universes, even if they existed, would in essence be just replicas of ours, and the apparent tuning would be no less a mystery than if our single universe were the whole of reality. We'd still be perplexed that a set of numbers imprinted in the extreme conditions of the Big Bang happened to lie in the narrow range that allowed such interesting consequences 10 billion years later. But there's another possibility. The overarching laws that apply throughout the multiverse may turn out to be more permissive. The strength of the forces and the mass of the elementary particles may not be uniquely fixed, but could take different values in each universe.
If the constants do vary throughout the multiverse, then Rees argues that our universe's fine-tuning wouldn't be mysterious. Rather, it would naturally result from the random variation of the constants in an infinite multiverse. As such, a multiverse with varying constants emerged as an attractive solution to the problem of fine-tuning.
For those of you who listened to our first series, you might have noticed the great similarity between scientists' reasoning from fine-tuning in support of an infinite varied multiverse and our arguments from fine-tuning in support of an intelligent cause. And while they are similar, we'd like to highlight one similarity and 2 important distinctions between the fine-tuning argument for the multiverse and the fine-tuning argument for God.
The key similarity is that both multiverse scientists and we agree that fine-tuning is a unique problem that implies there's no reasonable way to explain the constants of nature if all that exists is one universe. We both recognize that making sense of our one fine-tuned universe demands the existence of something outside the universe. The critical question is, what is this something?
While multiverse scientists say it's an infinite number of other universes with differing constants, such that our fine-tuned constants result from chance alone, we say it's an intelligent cause that selected the values of the constants for the purpose of bringing about our complex universe.
Either way, we both agree that it's not only legitimate, but also necessary to infer from fine-tuning the existence of something else beyond our one universe.
Now, let's move on to the 2 differences, beyond the obvious difference that scientists infer the existence of an infinite varied multiverse, while we infer the existence of an intelligent cause.
First, while our argument is based on the fact that the constants are fine-tuned for galaxies, stars, planets, molecules, life, and so on, in other words, complexity, order, and structure, multiverse scientists focus on the fine-tuning that's specifically necessary just for intelligent life.
This is because multiverse scientists explain our observation of the fine-tuned constants as the result of the observational bias of intelligent observers. That's why they often call their line of reasoning the anthropic principle, because it places humans in a unique position where our very existence places constraints on the constants of nature that we're potentially able to observe.
However, there's a problem with having humans play a role in explaining the universe, even if it's only in an accidental manner through observer bias. This problem manifests itself when multiverse scientists attempt to justify the typical universe premise, that everything we observe in our grand universe is typical for a universe with intelligent observers. While we certainly need certain laws and constants to have intelligent observers like ourselves, do we really need 100 billion other galaxies with 100 billion stars each? Does our entire complex universe follow from the mere requirement of having any intelligent observers? Can observer bias truly explain it all? This problem in a more developed form will ultimately lead to something called the measure problem, the death blow for multiverse's attempt to explain fine-tuning.
Whoa, Aaron, relax. You were doing so well until now. We've barely even explained the typical universe premise yet. The main point is that while multiverse scientists can try to use an observer bias to explain our own existence by chance alone, this doesn't explain all the rest of the complexity in our enormous universe. Don't worry if you don't fully appreciate why this is so problematic. We'll develop the point in greater depth in later episodes.
I got it, Ellie. I just get very excited about the measure problem.
I understand, Aaron. Let's just stay focused. While multiverse scientists' version of the fine-tuning argument revolves around human existence, our argument takes an entirely different path.
Our version of the fine-tuning argument follows from the existence of galaxies, stars, planets, molecules, and atoms. We argue that all the great order, structure, and complexity found throughout the universe, not just life, indicates an intelligent cause of the universe. While we don't exclude intelligent life, it doesn't play a central role in the formulation of our argument. This accords with humanity's apparent smallness relative to our immense universe.
Now for the second difference between scientists' reasoning from fine-tuning in support of an infinite varied multiverse and our argument from fine-tuning in support of an intelligent cause. While we argue that fine-tuning directly indicates an intelligent cause, scientists must infer a multiverse via a process of elimination.
This is because the scientific observation of one fine-tuned universe doesn't directly point to an infinite varied multiverse. On the contrary, an infinite disordered multiverse with varied laws and constants is the most shocking conclusion to draw from the observation of our one incredibly ordered universe with fixed laws and constants.
Despite its counterintuitive ring, scientists use fine-tuning to indirectly support the varied multiverse premise via a process of elimination. They reason as follows. If the values of the constants never changed, meaning if the constants were truly constant, then multiverse scientists believe they have ruled out all other possible explanations for fine-tuning. That leaves them with varying constants as the only remaining possibility.
The problem is that an argument by elimination always has the weakness that it's contingent on starting with a list of possibilities and then demonstrating that that list is exhaustive. Multiverse scientists think they've eliminated all possibilities to explain fine-tuning besides an infinite varied multiverse, and in fact, we almost completely agree with them. There really aren't any other good explanations for fine-tuning, with the important exception of an intelligent cause.
On the other hand, our fine-tuning argument didn't involve a process of elimination. Instead, we argue that fine-tuning, design, and order are the hallmarks of intelligence. If one were to start an honest investigation of whether or not the universe has an intelligent cause, the way to proceed would be to check and see if the universe exhibits fine-tuning, design, and order. And since it does, our amazing universe directly indicates that it has an intelligent cause. This type of reasoning doesn't have the weaknesses of an argument by elimination.
That being said, in episode 10 of season 1, we strengthened our argument by demonstrating that the only two theories that can reasonably explain fine-tuning are God or the multiverse. This laid the groundwork to show that once we eliminate the multiverse as a possibility, as we'll do in this series, the only remaining option will be an intelligent cause. So while we will ultimately eliminate all possibilities other than God, since fine-tuning, design, and order directly indicate an intelligent cause, our argument is much stronger than one that merely relies on elimination.
In a nutshell, while we use elimination to add additional support for our direct argument for an intelligent cause, multiverse scientists base their entire argument upon elimination. This creates the following major problem for them.
To see how scientists' process of elimination is predicated upon the implicit assumption that an intelligent fine-tuner isn't a viable possibility, let's lay out their line of reasoning from the beginning.
First, scientists reject all the naturalistic explanations of the constants that fail to address fine-tuning, for the reasons we discussed at length in season 1. Then, they summarily dismiss the possibility of an intelligent cause, because they begin with the assumption that God isn't real, and thereby argue that a varied multiverse is the only remaining contender.
Notice that this entire line of reasoning rests on the unjustified premise that there's no intelligent fine-tuner. On the other hand, if an honest investigator would begin with the open possibility of an intelligent cause of our universe, then fine-tuning, order, and design, the hallmarks of intelligence, provide direct arguments in favor of an intelligent cause.
The main point is that it's not legitimate for multiverse scientists to use an argument by elimination to establish the existence of an infinite varied multiverse as the only remaining possibility to explain fine-tuning, unless they truly eliminate the very real possibility of an intelligent cause.
It's an even bigger omission when you realize that an intelligent cause is not just another random possibility. It's what fine-tuning naturally indicates. The reason scientists think they have a good argument by elimination is because they simply don't consider an intelligent cause as a serious possibility.
One of the clearest and most explicit examples of modern scientists' unjustified premise that God doesn't exist can be found in physicist Lee Smolin's Three Roads to Quantum Gravity. In its final chapter, when discussing how to explain the laws and fine-tune constants of nature, Smolin raises all the key issues we've been discussing in this episode. Go ahead, Aaron.
Smolin writes as follows. Among the different possible consistent theories, how has one chosen to apply to our universe? There seems to be only one possible answer to this question. Something external to the universe made the choice. If that's the way things turn out, then this is the exact point at which science will become religion. Or to put it better, it will then be rational to use science as an argument for religion. It seems that the universe we live in is very special. For a universe to exist for billions of years and contain the ingredients for life, certain special conditions must be satisfied. The masses of the elementary particles and the strength of the fundamental forces must be tuned to the values very close to the ones we actually observe. If these parameters are outside certain narrow limits, the universe will be inhospitable to life. This raises the legitimate scientific question. Given that there seem to be more than one possible consistent set of laws, why is it that the laws of nature are such that the parameters fall within the narrow range needed for life? Notice that this argument is valid only if there is no way to explain how the laws of nature might have been chosen except by invoking the action of some entity outside our universe. You may recall the principle with which I started this book. There is nothing outside the universe. As long as there is a way of answering all our questions without violating this principle, we are doing science and we have no need of any other mode of explanation. If we want to stick to our principle that there is nothing outside the universe, then we must reject any mode of explanation in which order is imposed on the universe by an outside agency.
Aaron, our listeners are probably interested in knowing how Smolin justifies his first principle that there is nothing outside the universe.
Of course, Ellie. At the very beginning of his book, Smolin explains this point as follows. It is true that the universe is as beautiful as it is intricately structured, but it cannot have been made by anything that exists outside of it, for by definition, the universe is all there is, and there cannot be anything outside it. So the first principle of cosmology must be, there is nothing outside the universe.
What? So Smolin's first principle, that there is nothing outside the universe, is just an unjustified premise that results from his definition of the physical universe as all that exists?
Right. It's the starting point on which he builds all his subsequent theories. And his first principle, that there is nothing outside the universe, in other words, that God doesn't exist, rests entirely on his definition of the universe as all that exists.
Wow, that's hard to believe. Before I question that more fully, I have another question. Didn't we say that everyone agrees that explaining fine-tuning demands the existence of something beyond our one universe, be it God or a multiverse? But Smolin just said that there's nothing outside the universe.
Good catch, Ellie. Smolin doesn't mean that there is nothing outside of our one universe. While Smolin himself doesn't believe in an infinite varied multiverse, he does maintain that fine-tuning necessitates positing the existence of many ordered universes with different values of the constants, a theory he calls cosmological natural selection. While this may sound like a multiverse theory, it's actually very different.
We'll address Smolin's theory in a later episode and show how even though it has significant flaws, it's still better than an infinite varied multiverse. For now, the point is that when Smolin says there is nothing outside the universe, he really means there is nothing metaphysical outside the universe. Or more specifically, that God doesn't exist.
Right. While Smolin isn't the only modern scientist who harbors the premise that God doesn't exist, he makes explicit that which remains hidden for many other scientists.
Of course, the entire line of reasoning that all these scientists use to support a varied multiverse is deeply flawed. It's not legitimate to begin a genuine investigation of whether or not there's an intelligent fine-tuner of the universe by assuming there isn't one. There's simply no logical justification for beginning the investigation with the premise that the ultimate cause of the universe is not intelligent.
Rather, to properly determine if the ultimate cause of the universe is intelligent, one must first observe and analyze the universe's properties, and only afterward assess what they indicate about its cause. Without first conducting this type of honest investigation, the argument that fine-tuning the constant supports an infinite varied multiverse, instead of an intelligent fine-tuner, is guilty of assuming its conclusion.
To be fair to multiverse scientists, their unjustified premise may be based on the fact that they immediately identify an intelligent fine-tuner with a childish notion of God that they learned about in their youth. Because they believe that idea of God to be immature and flawed, they don't treat any idea of God, even a sophisticated one, as a reasonable possibility. In our opinion, this is the primary reason that multiverse scientists think that fine-tuning points to an infinite varied multiverse instead of an intelligent cause.
And that's why it's so important for us to complete our argument with our next series on God, in which we'll answer all scientists' objections to the theory of an intelligent cause and present a clear, logical, consistent, intuitive, and compelling idea of God.
But we're getting ahead of ourselves. Before we get to all that, we have much more to discuss in this series about the multiverse. In our next episode, we'll discuss string theory and explain the second method multiverse scientists use to support the varied multiverse premise. So stay tuned.